BIM Level 2? Well, the British Standards Institution describes BIM Level 2 maturity as a series of domain and collaborative federated models. The models, consisting of both 3D geometrical and non-graphical data, are prepared by different parties during the project lifecycle within the context of a common data environment. This requires an information exchange process which is specific to that project and coordinate between various systems and project participants. This provides a platform to improve the coordination and design, provide outputs via digital transactions in a structured and reusable form. So essentially, it is a managed 3D environment with data attached, but created in separate discipline-based models. These separate models are brought together at agreed intervals to form a federated model, but do not lose their identity or integrity. Data may include construction sequencing and cost information. So simply, Level 2 involves developing building information in a collaborative 3D environment with data attached, but creating separate discipline models. A word that we've used throughout that process of explaining BIM Level 2 is the word model federation. So what does this mean? Well, a federated model is a combined building information model that has been compiled to amalgamate several different models into one, or by importing one model into another. The federated model can be used for clash avoidance, programming, materials management, site logistics, constructability review, amongst many other things. This will be explained in greater detail in Learning Outcome 1.4. So what exactly is involved in a BIM Level 2 process? Well, let's look at this in a bit more detail and understand what actually Level 2 requires. And let's also look at what the other BIM levels require as well. By understanding this, we'll gain an appreciation of what requires a successful BIM Level 2. The diagram here was developed by Mark Bew and Mervyn Richards. In essence, it's all about communicating expectations. The wedge highlights the current standards of the time, but also documents standards, guides, and classification systems that will be required in the future. Today, the primary standard is ISO 9650, which will explored later on in this lesson. So let's start at the beginning. Level 0. Well, Level 0 is defined as unmanaged CAD. This is likely to be 2D with information being shared by traditional paper drawings or in some instances digitally via PDF. Essentially separate sources of information covering basic asset information. Level 1 is a mix of 2D and 3D information using BS 1192. With a collaboration tool providing common data environment. Level 2, which we've already looked at, is essentially described as collaborative BIM. A federated model information is shared within a common data environment. And while Level 3 BIM has not yet been fully defined, the UK Government's Level 3 strategic plan sets out key measures which will be required in order to begin to successfully execute a Level 3 standard. BIM can be used throughout the whole life cycle of a project. If we take a look at the image here, we can see how it can be used at the different stages. BIM is not just confined to one specific part of a project. It can be used throughout the whole of the life cycle process. It can be used in the conceptual design, it can be used for detailed design, to generate analysis, to create documentation, used within the fabrication process, you can use it on site for construction, as well as construction logistics, and then it can be handed over and used for the running of the building. And then it can be used down the line for possible renovation or demolition decisions. So let's look at each one of these in a bit more detail, starting with the conceptual design. Well, BIM can be used to flesh out your design concepts before even moving toward a more detailed drawing design software. Software packages such as Autodesk Format allow anyone to sketch, collaborate, analyze, and revise early design stage decisions. The link below details this package in action. The detailed design. Well, BIM technology has offered the ability to define parametric constraints within the object's parameters so that when changes occur in a model, certain geometric relationships remain as the constraints impose them. Simply, this means that the information in a BIM model, compared to a CAD drawing, is intelligent and knows that it is associated with other objects. This enables a detailed and intelligent model to be created, which can then be updated throughout the construction process. This model, because it contains intelligent information, can be used to inform the design process. And one aspect of this, with this information contained within the model, can be used to create detailed analysis. BIM can increase building performance quality through early evaluation design alternatives by using analysis simulation tools to investigate if the proposed scheme meets the building's functionality and sustainability requirements. All drawings can be printed from the model, including 2D plans. There are tools that also enable you to print specifications from the model, room data sheets, amongst many other types of documents. The model should always be used to generate drawings and not the other way around. Digital fabrication for architectural design is the process of using computer-controlled machines for manufacturing physical objects by leveraging the geometrical output from a BIM 3D model. Digital fabrication enhances design insight and design communication. A BIM model, the fabrication can drive CNC routers, laser cutters, and 3D printers. We can then use the model on site, as well as to record information through the construction process. BIM technology has now been extended throughout the whole construction process, so as to guide the construction and make efficient design analysis, such as constructability reviews, programming, materials management, site logistics, amongst others. Where 4D technology has been embraced, direct savings and an increase in productivity have been seen. The use of 4D enables considerable savings to be made on construction projects by identifying problems prior to construction and avoiding rework during the project. When estimating project costs, estimators primarily do manual takeoffs, and this can result in human errors and potentially lead to inaccuracies in estimates. Technologies such as BIM have the potential to impact cost estimating in a significant way, as it enables automatic quantification and the production of schedules, which will largely eliminate the need for manual takeoff. The model can be used for preventive maintenance and scheduling. The BIM model can allow facility managers to evaluate different maintenance approaches, analyze data to make repair versus replacement decisions, and document the effectiveness of a reliability-centered maintenance program. Using information in the BIM model, facilities managers can evaluate the cost implications of changing or upgrading building assets, track the performance and maintenance of a building's assets, as well as producing accurate quantity takeoffs of current company assets for financial reporting and estimating. Also, the model can be used for space management, as it enables the facilities team to analyse existing use of space, evaluate proposed changes, and effectively plan for future needs. Further down the line, if one requires renovations or demolition, the model can be used at this stage as it will contain an accurate as-built of all the information within the building, as well as a historical database in the construction process, with this information being used to provide data for intelligent decisions when it comes to this part. If we look at this diagram here, what it represents is the Reba digital plan of works. This sets out 7 distinct stages with graphical information within the model and non-graphical information, and the stages that they are to be delivered, and to what level of detail. These stages are brief, concept, definition, design, building and commission, handover, and closeout and operation. Within the UK's context of Level 2 BIM, the different stages of how BIM can be used in the design process, which we looked at previously, are usually fitted into these 7 key stages. This ensures that data is produced on time in a structured manner and can be e-validated by the team that are required to do so. BIM is not just confined to one specific area, as we discussed. It's also not just confined to one particular profession. It can be used throughout the design by the whole design team. The model can enable a client to feel closer to design as they can easily understand the 3D model compared to traditional 2D plans. The architect, structure, M&E engineers can all create their own models, which can use for their own purposes to help with design decisions. But this can also be federated to help eliminate a number of potential clashes. The contractor can use the federated model for clash avoidance, site logistics, and programming. The quantity surveyor can provide detailed costs from the shared model, as well as those on site for installation can use the cloud to access the model and through their portable devices better understand design installation, ensuring to keep to best practice. Once the model is handed over, it can be then used by the client's team. As a final deliverable will have a historical database for the building, and this can be linked with other enterprise softwares to perform further capabilities. If we look at this image here, what we can see is an iceberg. And with all icebergs, top part that extends over water is quite small compared to the part that lies underneath. Well, BIM is similar to an iceberg, as only a small number of BIM requirements deliverables are seen, while most remain hidden below the surface. The BIM requirements that most people would know is that it requires software, it requires hardware to run that software, and requires the training of staff. Well, underneath, if we look at the iceberg, there are a lot more requirements required in order to execute a successful level 2 strategy. We need standards such as ISO 9650, which we will look at, guides, workflows, change resistant procedures to ensure that BIM is successfully championed within the company, role mutation, so people's roles may change, and new roles could be created as a result of bringing BIM into an organization. How do we understand what's a good and bad model? So we need model quality Q&A procedures, collaboration techniques and processes in order to ensure that information is being shared effectively. We need a use of different contracts because there's different deliverables, as well as matrix understand if what's been applied has been successful. In regard to BIM deliverables, most people would understand that with a BIM model, some of the key benefits are 3D visualizations, coordinated drawings, as well as production of basic quantities. Well, as we explained and we looked at BIM through the different process, we know it can do a lot more than that. It can be used for thermal studies, lighting analysis, structural analysis, constructability review to help in prefabrication, to track assets, BIM GIS overlap, photogrammetry, as well as being used inside through field BIM. So how do we get there and where do we start? Well, the key document is ISO 9650. This recognised standard internationally. It represents a standardised approach to using BIM for the delivery phase of assets. This standard contains all the same principles and high-level requirements of BIM Level 2 and is closely aligned with the UK 1192 standards. The first two international standards of the series are Part 1, Concepts and Principles, and Part 2, the Delivery Phase of Assets. The delivery phase of assets outlines a life cycle approach to structuring information for a project. This will be looked at in greater detail in microsegment 3 of 3 in regards to Learning Outcome 1.3. Before moving on to 1.3 Part 3, I'd advise you to look at these additional resources. There are videos here put up to help further explain Level 2 BIM maturity, the level of detail required, as well as a bit of information on standards. There's also been a case study uploaded onto the BIMSTAR platform, and this case study looks at the application of BIM through the whole construction process.